And welcome to the Atma Paradigm, consciousness-based science. And this particular talk is part of part one of the series of the Atma Paradigm, which focuses on consciousness. And this is session 4, entitled Brain Failure, More Hard Problems. We did talk a little bit about what we meant by the hard problem last week. And of course, the hard problem only exists because of the effort to try and explain the nature of consciousness in terms of what the brain can do. And for those, because we'll be presenting, not in today's talk, but in a future talk very soon, we'll be presenting an alternative approach which shows that the brain, the hard problem, is not really an issue if you approach the whole subject of consciousness and what it is, where it comes from a different angle. Now, just a quick summary of last week. We spent the time talking about QUALIA. And you'll remember some of the aspects we said about QUALIA. They are real because they are the qualities of all of our inner experiences. Everything we experience about the world comes through our senses, goes into our mind, and QUALIA are the qualities of all those impressions and experiences and sensations, emotions, everything that's within our mind. And they defy all our attempts to reduce them to the laws of physics or the properties of physics or any of the processes and functions of the brain. And we'll be exploring a bit more of that in this talk today. Hence, QUALIA are considered the unanswered phenomenon of consciousness. They are the hard problem. So, brain failure, more hard problems. We're going to look at this notion that can you explain consciousness from the viewpoint of just what the brain can do. We're not saying the brain isn't important. We're not saying it's not incredibly complex and wonderful, but it is not responsible for consciousness. And that is something that we have to show. And today we're going to show you that the brain actually isn't as capable or as responsible for as much as you might think. And it needs a lot of help in order, from some other source, in order to for you to be provided with the detail, the quality of the experience that you have at every moment of your waking life. So, we mentioned last week the proverbial red ball and what it is like to experience this. This is a meditation on what it is like to experience the redness as redness. We're not talking about your experience emotionally of red or psychologically how it affects you, but rather just as the experience of redness, just as a colour in itself. We looked at how light comes from an object, enters our eyes, and that sets up a message into the brain, shown here as a kind of digital bit of data buzzing around in our heads. But the wonderful thing is that we experience that data not as electricity, not as something we know of in physics, but in terms of a picture in our minds, a picture with colours. And we showed how colours, are that the colours that we experience are personal, they're subjective, they cannot be broken down to the laws of physics. So we're going to, that was visual. Now we're going to explore QUALIA from the point of view of sound. And here's an old chestnut, if we can call it that, the conundrum that if a tree falls in a forest and there's no one there to hear it fall and hit the ground, is there a sound? Now, of course, for this we've got to ignore all the fact that there's lots of other living entities, but we're talking very human-centric here. So if the tree falls in the forest, is there a sound? And I phrase that very particularly. Is there a sound? And we've got a little poll going at the moment, and if you're able to join that on the Facebook, you've got a couple of choices. You can say yes, there's a sound. No, there's no sound. Or don't know. Or you can suggest that it's a silly question. So have a vote on that. It'd be interesting to see your view. If the tree falls in the forest and there's no one there to hear it, is there a sound? Now, actually the reason that this conundrum works is because sound has two completely different meanings. They seem to be very closely related, but actually they're very different. One of them is sound as it is understood in physics. The production of longitudinal waves in a medium like air, or it can be through solids and water and so on. So it's a longitudinal wave in a medium. So in that case, you might say, something has crashed to the ground, it has set up a vibration, there is longitudinal waves in a medium. So in physical terms, there is what we would call a pressure wave. But is it sound? Or is sound, from the philosophical, psychological point of view, is sound one of the ways that we can have a conscious, subjective experience of a physical event which is fed to us by our senses? So is sound simply the physical phenomenon of a pressure wave, or is sound something that is experienced inside? So even if the pressure wave is there, is that a sound? Because sound, in terms of what we experience, is internal. And we can never know what... there is no experience then of a longitudinal wave unless there's a conscious entity experiencing qualia, the qualia of sound, as that thing we hear in our minds. So let's go on a little further on this and look at the two different aspects of the transmission of sound. And I want to introduce you to this little doofer here, it's called a kalimba. It's actually got many different names. It's kind of like a thumb piano, and you can play it by just putting on these little keys here. So you can make little noises. If I put it on the table, you can hear it better. So there it is on the left, but one of those keys is vibrating away. And that sets up this pressure wave which comes into our ear. So people think, well, that's sound because it's the pressure wave we're hearing from outside. It's an event out there. Okay, the pressure wave goes into our ear and you can just about see the eardrum in there, the tympanic membrane. And that's just basically a flap of skin. So when the moving air hits it, well, the skin starts to vibrate in a similar way. And that moves three little bones, the osculi here, which then transmit that vibration to what's called the cochlea here. Now, is sound the flapping of a skin? Is that sound? It's movement, it's vibration, but is it sound? Is the moving of those bones sound? Hard to kind of really call it sound in terms of experience. In fact, it almost seems that whatever was the sound from outside seems to have been lost in this process. Now we have this stirrup, which is pressing on a little window on the cochlea. And by doing that, it's moving the fluid within this kind of snail-shaped organ that we have. And by moving that, the fluid, there's a kind of wall up the middle of the spiral, and then that moves slightly, and because of that it then sets off a reaction in little hairs on the other side of it, and because those hairs move, then they fire a little electrical signal from different parts of the spiral. You can't really say there's sound in there. And now we've got a digital message, a bit of electricity, an electrical signal being heading off towards the brain, and we show that on the right. There's a neuron connecting and picking up inputs from other neurons and passing them on. So now what this thing we call sound as vibration has lost all sense of vibration. It's now simply just neurons firing, and that means chemical ions jumping from one cell to the next. Where's the sound gone? Or is it that the sound hasn't really happened yet? Because however, whatever our brain has got in terms of digital information, the fascinating thing is that we don't experience that as that electricity. We experience it as this musical note. It has a different quality, a different feel to what is experiencing this note, or to experience a thud. So how does the brain produce the experiences that we have? That is the hard problem that we discussed as qualia. That qualia are our internal experience of something which is so essentially different from the way that data exists within our brain. And the brain has got nothing else, no other way of conferring and transmitting or transforming that data. We cannot find anything else. All we know, it's got data, but that's not the music we hear. Then there is no player that takes that data and produces it as music. There's nothing like that in the brain. So this is an example of qualia, and it's a sort of issue that we're trying to explore today. We talked about the different types of qualia, the ones rising from sensory stimulus, from visual, audio, sensation, touch, smelling, taste, and so on. And we also mentioned the internal sensations, happiness, fear, hunger, and so on, anxieties, thoughts, ideas, desires, memories. They've all got a form of qualia connected to them. There is something that it is like to experience each of these internally. So in conclusion, we said features of qualia: it is real. There's nothing subconscious about qualia. They're what you experience. They're actual. In fact, they're all that you ever experience. They're subjective and private and ineffable, which means that the experience of them cannot be communicated. You have to experience them for yourself. And they have irreducible qualities. They have qualities which we cannot reduce to anything that we know of in the brain or anything that we know of in physics. So now we kind of look at why there is this contention that, for shorthand's sake, I'm just going to call the brain model. And I define the brain model as the belief that all aspects of consciousness can be explained completely by reference to the neurological functions of the brain. Explained completely. Not just that it plays a role, not just that it's helpful, not just that it's a kind of amazing little bit of biological machinery, but that all aspects of consciousness can be explained completely by reference to the neurological functions of the brain. That is the task of the brain model. That's its assertion. And believe me, it is an assertion that is real. Here's an example of just a couple of years back from New Scientist. They did a special publication, How the Brain Works. And here is their statement: you are your brain. Everything that makes you you and all your experiences of the world are somehow conjured up by 1.4 kilograms of grey matter inside your skull. So that's a pretty heavy statement. They really believe that. But actually there is no evidence for this. And this is what we're going to show, that actually it's so problematic. No one should be making such a statement. So does the brain model really explain what's going on? No, we're going to see that it completely fails. But let's have a few fun facts about the brain. The number of cortical neurons that you have is 86 billion. And yes, whales have more neurons than we do because they're bigger, but they don't have more cortical neurons. So humans are right up there. The grey matter is neurons. So the previous slide from New Scientist was wrong. The 1.4 kilograms is not all grey matter. Only 40% of it is grey matter. 60% of it is actually white matter, which makes up the axons and dendrites. But some people count those as the actual, count them as neurons because they're attached to them. The number of synapses or connections that each neuron can make with another neuron varies between 1,000 to 10,000. So that's an incredible number. There's 100,000 of miles of blood vessels circulating in your body, and that takes up 20% of your body's blood is there in your head, which shows just how much work this beast of an organ is doing. And it processes information at 268 miles per hour, which that's pretty fast, you know, even for a Formula One car, but it's not lightning speed. It's not even the speed of sound, certainly, and nowhere near the speed of light. So not that fast, and that has repercussions, and which I shall talk to you later about. And it's reckoned, and I don't know whoever tried to do this, but they reckon that we process about 70,000 different thoughts in a day. And that probably is a good day. There's days, I'm sure, when I kind of feel I've processed a lot less. And we have a power consumption of between 10 to 23 watts. Now, all these connections, all these numbers add up to a possible routes for neurotransmitters of 10 to the power 15. That's just an astronomical, that's just a number that we cannot even conceive of. That's the number of possible routes for, now they're not all used, and the idea that you only use 10% of your brain, you shouldn't be using much more. You know, it's not that we're meant to use up all of our brain in the same way as you're not meant to use up all the CPU of your power of your computer, otherwise things do clog up. So, but there's huge scope for what's going on then, which why when later on you see how little the brain is doing, you'll be quite shocked. Now, in all of this, the question is, where is consciousness? And that has been the quest, particularly in the last 50, 60 years, when we've had such incredible imaging tools to really explore what's going on in the brain. So recently, I attended a lecture by Anil Seth, and he explained that we know that consciousness is nothing, not to do with particular neurons. There aren't some specific neurons in your brain that we can say, they're responsible for consciousness. Some claims have been made like that in the past, but that's not true. It's not to do with the total number of neurons, nor the complexity of brain activity. The total number is not that we humans have got more cortical neurons than a mouse, and therefore we've got consciousness. It doesn't. We know that's not what's responsible for consciousness. Complexity of brain activity, you would think, well, surely that must be it. It's to do with all these, the amount of activity that your brain is sending and the data that's going all around the place. No. Because surprisingly, your brain is as active during sleep as it is when you're awake. So that's not the difference. And we know it's nothing to do with the specific areas of the brain. And that's often the claim that people will say, oh yes, we know the frontal area, that's responsible for emotions and all sorts of interesting things like that. And therefore maybe consciousness is linked and available in there. Nope, that's not true either. Anil Seth says, but maybe it's to do with networks and connectivity. Maybe it's the way that the information is passed around in some way. Now, we don't know how, we don't know why this would be the case, but we think since it's not anywhere else, we're thinking maybe that's our hope. Now, one of the guys who really wanted to study this and crack it was Francis Crick. He's the guy of DNA fame. He discovered the structure. He didn't discover DNA, but he discovered this structure, which is really kind of useful because then it helped to explain how it worked. And after he'd kind of found DNA and suggested a process by which the information became encoded in proteins called the central dogma, he then thought, well, job done on life. I've sorted life out. We'll come to that later. We'll see that it's a long way from being sorted out. But that was his mission, that I've sorted life out. Now I'm going to sort out consciousness. So in the late 80s, early 90s, he was working on consciousness from a neuroscience point of view. He wanted to really look at it very closely. He teamed up with a guy called Christoph Koch, and together they came up with NCC, which is the neural correlates of consciousness. He wanted to try and show which neurons are firing when we report ourselves to be very actively conscious. Now you can see the problem immediately, that you can show correlation, but correlation is not causation. Just because things are related doesn't mean that one causes the other. And he understands that problem. But still, this was his task. So they set about trying to explore the nature of consciousness, and they hit a brick wall. The same blockade that everyone who approaches consciousness through neuroscience hits. The hard problem of qualitative experience. Now, some of those images that I've shown you earlier were actually inspired by a diagram that Francis Crick and Christoph Koch produced in their paper, A Framework for Consciousness. Here it is here. And basically, it shows a guy receiving information about the outside world, and then we see into his brain, and then conscious perception. It all seems very nice. But let's drill into it a little bit more detail. I know it's sort of repetitive on what I've been saying, but I honestly think it's so worth it when we get this point. Okay, light bouncing off the objects in the outside world coming into our eyes. No issue, that's just basic physics. Goes into our eyes. How the eye converts that into data, which then goes to the brain. Yeah, we've got that sorted, no problem. And here it is actually, here's inside the brain. The yellow ring that I put there circles the primary visual cortex, called V1. It's Brodmann's area 17, right at the back of your head. And it's kind of quite small, really. For the amount of work that the visual processing is meant to do, that's not a huge area. The visual area also includes V2 and V3, and it suggests that they are likely to be involved in recognition or appreciation of what is being seen, but they're not actually dealing with the raw data directly. So V1 is the kind of the visual area. All right. Now, Francis Crick and his cohort are very competent. They understand what they're illustrating here, and just to show as a confirmation of the points I've been making, that they show the inside the brain we've got the neurons connecting there, the stringy things at the back, but really what is happening is data flow. It's information, and we can show that as NCC, neural correlates of consciousness, or at least we can show this in a barcode. You know, so it's a digital packet of information. That's what the brain's got. But the interesting thing is then this next bit. They just show an arrow going from that barcode data to the image, the conscious percept. That image that we see inside ourselves. As we said last week, you just cannot take it for granted that because you are looking out in the world, you should see a picture. That picture of the outside world has been converted into a digital file. Why is it now an image in your experience? That becomes the question. So there's no answer to this. So others have analyzed all this and they said, well, look, obviously in neuroscience, we've got two elements. We've got the easy bit, which we don't know argument about. Light going into the eyes, going into the brain, setting up networks of in the visual cortex area. No problem. It's this bit. That's the hard bit. What's the process? What's happening here? Why is this? Why does it happen? Who is it for? This raises all the questions. And just putting an arrow in your diagram doesn't address the problem. So, we're not saying the brain isn't amazing. It's, you know, it has been described as perhaps the most complex thing we know of in the universe, which is a bit of an overstatement. We don't know the rest of the universe. At least on this planet, we can know that it's a pretty complex thing. But still, and it does important stuff, processing all the data from our brain, from our senses, but it's incapable of accounting for everyday experience. So we need to kind of give up any thought that the brain can produce or explain consciousness. We need a new idea. Now, just to show you that this is a hard problem, I want to read you this quote. the most difficult aspect of consciousness is the so-called hard problem of qualia. No one has produced any plausible explanation as to how the experience of the redness of red could arise from the actions of the brain. Now, think of that statement in terms of what we have just experienced. This idea that you can put a diagram with an arrow showing the experience of qualia. And now we have this statement. Actually, no one has produced any plausible explanation. And the interesting thing is, do you know who said this particular quote? It was Francis Crick himself. And do you know where he said it? In the same paper as that diagram, A Framework for Consciousness. So here he is trying to present a theory, an explanation for consciousness, but admitting that whatever he is doing, it's not explaining qualia. It is not dealing with the hard problem. It is not an explanation of the experience of qualia. So we can't really count it as an explanation for consciousness. So if Francis Crick has set himself the job to crack consciousness, on this aspect he has failed miserably, perhaps. Now, we've really just analysed the big issue that the brain cannot account for qualia experience, the qualitative experience of the world that we have in our mind. But actually, it's not even as simple as that. There are lots of other problems for the brain model in order to try and deal with life as we know it. And I'm going to take you through the first one, called sparseness. Sparseness is an issue that affects all sensory input, but I'm going to just look at it from the visual point of view because we focused a lot on that. So this is how it works. The quantity of data coming into the brain, that's what we're going to look at. First, the amount of bits of data that come in from the outside world into your eyes at every single moment. That's 100 billion bits. Now, a bit of information is basically the binary on-off 0-1 bit of information. So that means that there is 100 billion light rays that are capable of setting off photoreceptors in your eyes. 100 billion. However, you don't have 100 billion receptors. You've probably got between 800,000 and 1.7 million, I think it is, in each. You've got 120 million cones and was it 7 or 8 million? 120 million rods which do the black and white, and about 7 or 8 million cones which look at the color bit. So not all of them. Not all the rays of light set off transmitters, and also each of the rods and cones has to have a resting period. When it fires, it has to rest before it can fire again. So that 100 billion is not going to remain 100 billion. In fact, once the light has been converted into electricity within the retina, and all that data is now gathered at the top of the optic nerve, ready to go to the brain, you've dropped from 100 billion to 6 million. Quite a loss, quite a big difference there. Now, as it travels down the optic nerve, there isn't even enough nerves within the optic nerve to handle 6 million. There's also loss all the way along the line. So by the time that those signals actually arrive at the Brodmann's area, 17, then it's down to just 10,000. That's a drop of what, 10 million fold? 10 million, 1 in every 10 million light rays that's coming into your eye actually is a bit of data that reaches your brain. The bit of brain that you're really concerned of, the processing area. And it's reckoned that not even that 10,000 bits of data is being utilized. The estimate is that used to generate just one single image at every moment for you, The whole image that you are getting at this moment is being generated using about 500 bits of data. Now, for those who are not used to dealing in bits of data, let's convert that to pixels. It's the equivalent of about 20 pixels for a color in a color image. It takes 3 pixels, 3 bytes, which is 24 bits, in order to specify a particular color. And the brain actually works sort of similar to that. But let's just think of it, if you had a camera that has a 20 pixel camera, you wouldn't expect to see very much. But the interesting thing is that we do. We experience, and I'm using the Alsatian because it was part of CRICK's diagram. We experience our impression of the dog in great detail. It's very precise, it's very accurate. That's how we experience it. But when you actually analyze the data content of our brain, that's a mystery. We probably should be seeing it something like this. And that may even be being generous with 20 pixels worth. So that's visual sparseness. It's a known problem, but it is not discussed. Why? Because it really hurts the dogma that the brain is you and that there's nothing else. Not only can you not explain qualia, the qualitative nature of our experiences, you cannot even explain it quantitatively in reference to the brain. Which is why people are now saying, well, we have to recognize that the brain simply is a guessing machine. The brain makes its best guess at what's going on based on the input of the senses. So we're no longer able to say the brain is processing data and giving us this wonderful effect of the world. Now we're saying, no, it's just guessing. It has to fill in all the details. And in fact, Anil Sheth, who's the kind of leading neuroscientist researcher, I'd say, in Britain, based at the University of Sussex, he says, puts it even more strongly, he says, our perception is an hallucination, partially moderated by sensory input. So basically, he's not saying that the brain is using the sensory data in order to construct. He's saying you're hallucinating all the time, but occasionally your hallucinations are moderated or adjusted or changed by what you think is some sensory data coming in. Now this is giving you a very different picture of what you're experiencing. And remember, sparseness doesn't just apply to what you see. The same truth is there in terms of what you hear, the details of that. And we know that we're able to enjoy music which is highly complex and pick out all the different pitches and tempos and timbres that are going on within the music. But actually your brain hasn't got a fraction of that information. Is it just hallucinating? Is it just making it up? This doesn't make any sense. So there's been those who have studied what's called veridical perception. The understanding that, yes, although we are capable of being fooled by things that we see or hear, really, to a large degree, we enjoy direct perception of the stimuli as they exist. We have a perception of space which corresponds to the reality of our environment. We're able to reach out and pick up things, catch things, do things, move about. And without this, we'd be useless. If we really were simply just hallucinating or guessing in the way that people claim that the brain is doing, we would be utterly useless. And no amount of evolution would have got us to the point where we could be living in terms of hallucination. So it is not the way to deal with the problem. But the difficulty is, not only do they have the hard problem, they've got all these other problems, but they cannot get beyond the problems because they're not willing to give up the foolish original concept, the presumption that the brain can explain everything. The brain needs a lot of help, and it is not the thing that is conscious. It is not that which is conscious of. So here's another one. It's called the binding problem. Now imagine you're sitting by the open fireside. You hear the crackling sounds of the wood as the flames leap from it. You see the colours of the flames. You feel the warmth of the heat, the fragrance of the wood smoke. So a lot of different sensory expression, sensory stimuli, and also a lot of qualia connected with all those experiences. And mixed in with them, you're sitting there and your mind's just wandering and it's just feeding you ideas and thoughts and memories. So you're transported back to another time sitting by a fire, maybe when you were with friends, and then maybe an inspiration comes to you. Yes, I should contact so-and-so. I haven't spoken to him for a while. So all of this, it's not just do we have one sensory input, but there's an integration of all the different sensory stimuli mixed in with ideas, mixed in with memories, and it's all there as part of your total conscious experience. Can we explain how the brain does that? No, no, no. Because the different sensory things are happening in different parts of the body, in different senses, you know, and coming into the brain in different areas and being dealt with in different ways. They all end up as digital data, but how that digital data in one part of your brain is translated into an image, and another part of the brain that's translated into a sound, and another place it's a smell, that's totally inexplicable. And how they all work together, that's called the binding problem. How is a unitary perceptual experience generated that combines qualities, and this is just in terms of the visual, color, shape, location, and orientation. Never mind when we put it in with all the other sensory stimulus. And that's another killer problem for the brain. And it isn't even over yet for it. I'm afraid I'm kicking the brain model when it's really down. But let me put in one more kick. That's all we've got time for today, which is time lag. Now, we experience various sensory inputs simultaneously. You want to try this one. Reach down and with your left hand, touch your foot. And with your right hand, touch the tip of your nose. Now do it simultaneously. And you experience them together, don't you? But that's weird. You shouldn't. Because remember that figure of 268 miles per hour? It should take much longer for the sensation in your nose to pass to your brain than it does from your foot to get to your brain. And believe me that even 268 miles is quick, it's the time lag is actually serious in your experiential time scale. So that's not very good. And then if we look at different sensory things, that was looking at both touch, but in two different parts of the body. Now think of two different inputs. Please watch and listen very carefully. Now this may not come across so well in the because we're broadcasting with a delay, but it should still work. So, or do it for yourself, get a friend to do it. If someone claps, you see and hear the clap at exactly the same time, right? Now, that's amazing. Now, we're kind of doing this clap when it's close by. There's, you might think, well, there's a big difference between how quick sound moves and how quick light moves. But in a short distance, we experience them synchronized, okay? However, that's not true with what's happening in the brain. There's a delay between the brain processing oral information from the ear and visual data from the eye. It takes a different amount of time for the brain to deal with that data. I often, in a live situation, I might ask, which do you think the brain deals with first or quicker? And a lot of people say, oh, sight, because they're thinking of it in terms of the speed of light. No. You've got to think of this in terms of if your computer was dealing with an audio file or a video file, which would it open up quicker for you? And the answer is that because the audio file is, we recognize, you know, in computing terms, it's lighter. It's therefore the computer can deal with it quicker than it can deal with a video file. And it's whether that's exactly a parallel, it's the same is true of the brain. There's a big difference between the time the brain takes to process information from your ears than it does to process the information from your eyes. And the difference is a whole half second. And that's a figure given to us by neuroscience. That's an established fact. A half a second delay. Now, half a second might not, well, you think that's not very long. You know, if I was waiting for my dinner and someone said it'll be in a half second, I'd be very pleased. But a half second in terms of synchronizing sound and sights, in my experience, that's a long, long time. And this has led to the analysis that either we experience everything with a significant time delay, or the brain is feeding us information before it has happened, or certainly before it's been processed. Now, think of it like this. You're on the deck of the starship, and the captain is there saying, you know, I'm okay, I need to give reports up to high command consciousness. So what have we got? And the sound department says, well, we've got through, we've just had a noise come through, we've processed it, and we're not quite sure exactly what to link it up with as yet, but it sounds like some kind of bang, clap. It could be a clap, we think, but we don't have any further detail on it. Captain says, no problem, let's contact the visual department and they'll be able to tell us what it's all about. So the visual department come on, no. Yes, we've had something through, we're looking at it, you know, it's still in the works. Could you give us a little bit longer to process and we'll be able to give you an answer? The captain's going mad. No, I need to put something, I've got the sound. I need a sight, a visual thing to go with it in order to go to consciousness, because he expects to get sight and sound at the same time. I know, but it's going to take us another half second to be able to work all this out. So captain saying, well, what do we do? And sight says, well, I tell you what we could do. Why don't you hold back the sound? Don't pass that up to consciousness just yet. Wait until we've got our visual sorted out. Then we put them together and we release them at the same time. But that means there's been a complete time delay between the event and when consciousness gets the information. Okay, yes. Then visual says, well, okay, if that doesn't work, why don't we do it this way then? Just make up something for now. Just if sound thinks it's a clap, we'll give you some old footage of clapping that we have in our files. We'll put those together out now and we'll put it out. Consciousness will never know the difference. And the captain thinks, this is going to get me fired. This is hopeless. This is not how it works. And these are the two options. Neither of them are very satisfactory from anyone trying to promote the brain model. No one wants to say, really, that we experience life on a time delay. Some do, but a lot of people think that's really daft and, you know, that's not going to work very well. And the other one is that if we're simply guessing all the visual stuff in order to synchronize it with the speed of our hearing processes, that's not very good either. So none of these is acceptable. And imagine trying to play sports with it. Here's Roger Federer serving, and it takes less than half a second from when that ball leaves his racket to when it passes you behind the baseline. So if we're experiencing on a time delay, we'd never be able to play. Or cricket, half a second for a fast bowler from one end of the pitch to when it's smashing the stumps. You'd be saying, oh, he's just left the ball. No, my stumps are flying all over the place. And for those of our American viewers, here's rounders, baseball, slightly less time, 0.4 of a second between the pitcher throwing and when it passes the base plate. Now, the analysis that people have done on this shows, and Stuart Hameroff, who runs the consciousness studies in Tucson, he's a physicalist himself, but he understands this point, that actually all our professional sportsmen report that they are seeing the ball, if that's the game, in real time, and at that point they're making conscious decisions in order to how to deal with it. So they appear to experience and operate willfully in these very short time periods, but the brain hasn't actually caught up with them. Means we're operating faster than the brain can actually deal with all the data. Now that's a mystery, and that's a mystery that has to be solved, but it can't be solved by the brain model. You know? So some people then say, okay, well, we don't like the predictive one, that's not going to work very well. So maybe you just deal with the whole world on catch-up. That means that consciousness is experiencing existence in a half-second delay. Now, there's a huge price to pay for this contention. And therefore, don't think that I'm saying it. Don't think that you should believe it. It's daft. The price is that what they're actually saying is that, yes, you believe you experience the world, and you're actually experiencing it a half second after everything has happened, after all that the brain has actually dealt with the sensory data. And it's then feeding you stuff half a second later. And you might say, well, then how do I interact with the world in real time? And their point is, you don't. Because the idea of you is simply an illusion, and you are not involved. The brain is sorting everything out. It's moving your body. It's deciding everything that happens. You are just a passive observer watching what has happened after it has all taken place. You have no agency, no free will to change or influence anything that is happening to you. That is the price that you have to pay in order to claim the hallucinating brain. That, in philosophical terms, in real terms, in human terms, very, very few individuals would dare to make that claim, because it destroys everything we accept about ourselves. And basically it relegates consciousness to a nothingness. So it has to be understood that these sort of ideas, trying to, the guessing brain, the hallucinating brain, the idea that there's no self, that there's no free will, these are not coming out of positive proofs that neuroscience has been able to establish about what the brain is doing. It actually comes out of the opposite. It's because the neuroscience of the brain is not doing any of the things that we connect with consciousness. It is not providing for our everyday experience. It is not explaining qualia. It is not explaining free will. It is not explaining our sense of existence, not explaining any of those things. That's why they come up with these ad absurdum postulations. So the brain model can't explain unified consciousness, subjective experience, qualia, everyday perception, everything that we know for certain. So it kind of fails on all those things. We need a completely different way of understanding the nature of consciousness and how it interacts with the brain. And it is not to be found in any idea that the brain is responsible for all the important aspects of consciousness. It's a tool, it's part of the machinery of our body, it's vital for our interaction with the world, but actually, in real terms, it's not doing that much, and it certainly is not responsible for our state of consciousness. Now, I've got another little poll here, which is, just want you to kind of consider how well we've explained these points regarding the brain model. Is it not at all, somewhat, pretty good, or yep, I've got it. So take a moment to do that. And it also, we're just about to go into the Q&A. Last week we tried to do the questions and answers via Zoom. And that was actually good fun for those who took part, but only a very small number was actually with us on the Zoom call. So we kind of think we'd be better keeping it on Facebook. So if you'd like to kind of go on the Facebook, if there's got any questions on any aspect, if you could jot them down there. And Mantri Raj, who is my kind of assistant down there in Cardiff, is going to kind of look at them and send them through to me on a chat so that we can discuss them there. So there's a time delay, not only in our heads, but also in this broadcast. So while you're doing that, I'm just going to give a quick summary of what we've been discussing. The idea that we talked about the brain model. So the idea that the brain somehow generates consciousness is flawed. It fails as neuroscience. It cannot explain our experiences, an intuitive sense of ourselves. And it leads to absurd postulations, things that we know are not true about ourselves and about our experience of reality. So got a couple of questions coming through. First, there's more neurons in the visual cortex. Even though there are more neurons in certain areas of the brain, doesn't necessarily mean that there may be more data, and that's what we're suggesting, that the brain is having to deal with more data in visual terms than it does in perhaps audio terms, but still ultimately you get is data, and that doesn't convert into qualia, the qualitative experience of that. And still there is this issue of sparseness. That's very, very small amount of data that has been identified as the potential for representing any particular image. There's been another question regarding the effects of LSD, and he also asks about déjà vu. I'm going to cover some of the aspects of psychedelics at a future session, but just to give a couple of things where these things actually cause more problem for the brain model. There's certainly been imaging where subjects who have had ingested LSD or other psychoactives show a lot of activity on the brain. And what actually seems to happen, and I think this will be better explained when we show a model of how consciousness actually deals with the brain activity, is the brain almost gives up and just cannot, and it seems that what we're experiencing becomes a mixture, and it may even reach the stage of a form of synesthesia, where you may be having a visual input through your eyes, but you're experiencing that as a sound, or something comes into your ears and you experience that as a color. So that is a kind of synesthesia effect. Actually, it said that we all carry some kind of synesthesic aspects in our minds. I have one, which is a weird one. I experience the numbers 1 to 100 in a spatial format. So whenever I hear a number between 1 and 100, I see it on this kind of ladder. And that's a kind of form of spatial synesthesia. And don't think I'm weird, you've probably got one too. I'm going to leave the déjà vu because that's an interesting one for another time. So we've been asked, is there a practical application of this? Does this, what we've been analysing in terms of the brain, affect the type of job? And I would say no. What I'm talking about is not psychology here. I'm not talking about characteristics of one human or another. We're talking the general principle of what it is like to have a human brain. All our brains seem to work. I mean, we obviously produce a lot of variation in terms of our experiences and things, and there's certain disorders and things that certain people have. But in general, we're just talking generally, that you cannot assign consciousness to the brain. Later on, we'll be, further down in some of our later talks, we'll be looking at how all of this does start to manifest in kind of psychological traits, and there are ways in which that might actually help understand certain elements. And then there's a question that someone said, well, if I'm watching a Blu-ray or DVD and the audio is out of sync with the video, then I have to adjust it manually. Why don't our internal processes make this adjustment when it happens? Yes, that's the point. But there's only two ways to adjust it. Either you wait for the sound, you hold the sound until you sync it with the visuals. And remember, when you're watching a DVD, you're not watching real time. You are that sort of participant who's just watching it on catch up. It's been recorded and you can adjust it. But if you're trying to experience life in real time, you can't either hold back the sound and wait, until you've got the visuals, or try and generate the visuals before they've actually happened. That doesn't make any sense. That's why it's a problem in real life terms. I think there's a question about what are the scientific references about the properties of the brain and the eyes. All of the issues that I have presented are part of a kind of wide body of literature available on neuroscience. And you can probably look up all of these and find them in the, provided in different papers. I tend to like to read the original papers that are published by folk that are considered reputable and peer-reviewed by either a quality scientific magazine or within a university, so that I can present this with confidence. And particularly everything that I've presented has multiple citations and evidence behind it. So just the final point, it's been, someone has suggested, yes, but maybe the brain may not explain consciousness, but it is certainly not unrelated to it. And I hope that I have made that point clear, that what we experience can be determined or helped or impeded by the brain. What we experience, not that we experience. The reason that we experience stuff, that is the nature of consciousness. What we experience, the brain can help us, and that's the difference. And we need to understand how we use our body and our brain and our senses to experience the world. But the fact that we are able to experience the world, that ability of consciousness does not belong to the body or the brain. We are now going beyond that. We are now going to have to look at a non-neural source for consciousness. And with that, I think we're just going to have to conclude. I apologize that we started late and therefore have run over time today. But I hope that you'll join us next week for theories. Now, I'm afraid I haven't finished with trying to dispense with the idea that there is a physicalist explanation for consciousness. And next week we're going to look at not just the neuroscience theories, but all the other types, or as many as we can, of other types of theories. And I'm going to show you 4 ways to recognize a faulty explanation of consciousness. So I hope you'll be able to join us next week. I hope we start at 6 o'clock. That's Thursday the 21st of May. And thank you very much for being with us.